Hello everyone. Now, in the last session of processor and controller, we have discussed and we have started about microprocessor 8051. Right now, in this microcontroller 8051, in today's session, we will going to discuss about its architecture and its pin functions. Clear? Now, the topics to be covered in the following session, that is architecture of 8051 microcontroller, description of 8051, pin diagram of 8051 microcontroller, and pin description with its functions. Clear? Now, first let us see the architecture of 8051. Now, here it in the figure, it has been shown the architecture of 8051, where in between the first, that is the brain of the controller, that is nothing but CPU. For CPU to get processed, it is needed that it should be processed at particular frequency. So here the oscillator is connected to give the particular frequency of 8051 microcontroller. Right now, various parts or various peripherals are connected with the CPU. First, that is interrupt control, in which there are two external interrupts, which is INT 0 and INT 1. Interrupt 0 and interrupt 1. Right, then it will have a on chip ROM for program code, on chip RAM for data memory. So it will follow a Harvard architecture. Clear? Then it will have a bus control, where the various address and data buses will be controlled by this control bus, and various peripherals will be all connected with this. Then it will have a 4 IO ports, that is A, B, C and D. Right, that is 0, 1, 2 and 3, where these first two ports will be our address and used for address bus and data bus. Now, there is also a serial port for communication, which will have a transmission pin and receiving pin for transmitting and receiving data serially, that is bit by bit. And it will have a timer and counters, external timer counters, and two internal timers, which is timer 0 and timer 1, T0 and T1. Clear? So this is the whole architecture of 8051 microcontroller. If in exam it is asked about 8051 architecture, you need to draw this particular diagram. Clear? So it will have a various peripherals, and all these peripherals with the CPU are the embedded on a single chip. Right? So it is called a controller. Clear? Now we will see its description. So 8051 is designed by Intel in 1981. So it is an Intel chip of 8-bit microcontroller. Clear? So 8-bit data can be transmitted and receiving simultaneously. So next, that is, it is an 8-bit microcontroller. As we have discussed, that 8-bit data can be accessed. It has built with 40 pins DIP, that is dual inline package. So it is a 40-pin IC, same as microprocessor 8085, having inbuilt 4 KB of ROM storage and 128 bytes of RAM storage and two 16-bit timers. Right? So it will have, the controller will have ROM, RAM and two 16-bit timers on its peripherals or on its connection. It consists of 4 parallel 8-bit ports, which are programmable as well as addressable as per the requirement. Clear? So what it will have? It consists of all 4 parallel 8-bit ports, that is P0, P1, P2 and P3, all having 8 bits, so 32 lines for 32 pins for IO ports, right, which can be programmable as well as addressable as per the requirement. An on-chip crystal oscillator is integrated in microcontroller having crystal frequency of 12 megahertz. So the processor which we are using for 8051 microcontroller will work on the crystal frequency of 12 megahertz. Right, where we have discussed that the crystal frequency which we have discussed in 8085, which will have a 3 megahertz, right, and here it is a 12 megahertz for 8051 microcontroller. In the diagram, the system bus connects all the support device to the CPU. So all the peripherals which are embedded on a single chip, that are all main connected to a CPU. The system bus consists of 8-bit data bus, a 16-bit address bus and control bus signals, right? So similar as 8085, it will also have a 8-bit data bus, 16-bit address bus to carry the address of 16-bit. So maximum 2 raised to 16, that is 64 KB memory can be connected. External, internal it is 4 KB ROM, right, and 128 RAM. So externally you can connect up to 64 KB. And control bus signals. All other device like program memory, ports, data memory, serial interface, interrupt control, timers, and the CPU all are interfaced together through a system bus. Clear? So all the devices which are embedded on a single IC, that all are connected with the CPU and all are interfaced with the CPU through the system bus, which will have this 8-bit data bus, 16-bit address bus, and the control signals, right, for controlling the various and timing and synchronization signals for the various peripherals. Clear? Now, next topic we are going to discuss, that is pin diagram of 8085 microcontroller. Right? Now, 8051 microcontroller. Now, let's see here it is a 40 pin IC. Right? In pin 1 to pin 20, that is same as 8085, that is from top to bottom on the left hand side, and 21 to 40 from the bottom to top on the right hand side. Now let's see here, from pin 1 to pin 8 it is port 1. So port 1.0, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6 and 1.7. So it will have a 8-bit port 1 on the first left hand side, right? After port 1 completed, at pin 9 there is the RST pin, that is reset pin, right? Through reset pin, what it will have, it will 8051 controller will terminate all its activities and the program counter will be at the 0000 location. Clear? From 10 to 17 it will have a port 3, that is port 3.0 to port 3.7. This will work as the input output port, as well as it will have a alternate functions as well, right? So what are the alternate functions? So first, that is RxD. At 3.0 it is RxD for serial receiving purpose. At 3.1 it is TXD for serial transmitting purpose. 3.2 and 3.3 will having a external interrupts, that is INT 0 and INT 1, which are active low pins which active on 0. At P 3.4 and 3.5 it will have a two timers, T0 and T1, right? 3.6 and 3.7 they will have a write bar and read bar for reading and writing the data, right? Then 18 and 19 will be connected to the for the crystal oscillator, which will have a frequency of 12 megahertz, and last 20 number pin that is connected to ground. Now from here bottom 21 to 28, that is port 2, there is 2.0 to 2.7 will have a higher order address bus, that is A8 to A15, right? Then 29, that is PSEN, that is program storage enable, right, which is also a active low pin. Then 30, that is ALE, that is address latch enable, which we have discussed in 8085, and program bar. Then 31 will have EA, that is external access bar or VPP, right, for peripherals connecting. From 32 to 39, so starting from 39 to 32 reverse side, it will have a port 0, 0.0 at 39, 38 0.1, 37 0.2, same way 32 0.7. So it will have AD0 to AD7, that is multiplex address and data bus, right? Lower order address bus A0 to A7 and data bus D0 to D7. Here it is also same way like 8085, it is a multiplex address and data bus. And last, that is VCC. VCC, that is for power supply to power or to on this particular chip. Now which we will see each and every function in detail. Now from pin 1 to 8, so the pin 1 to 8 are known as port 1. This port does not serve any other functions. It is internally pulled up by directional IO ports, right? So as we have seen from pin 1 to pin 8, these are the port 1, that is 1.0 to 1.7, right? And they doesn't have any alternative functions. They are only purely work as IO ports, that is input output ports. Pin 9, that is it is a reset pin which is used to reset the controller to its initial values. Clear? Then pin 10 to 17. Then these pins are known as port 3. These ports serve some function like interrupts, timer input, control signals, serial communications like RxD and TXD, etc. So as we have seen in the diagram, from pin 10 to pin 17, it is port 3.0 to 3.7, right? And these work as an input output port, but also it works as alternate functions, like it will have a interrupts. For serial communication, it will have RxD and TXD pin. Then for timer, that is T0 and T1, and control signals, that is nothing but write bar and read bar. Clear? So these are the various functions, alternative functions through which port 3 uses. So if any alternate functions is needed for a controller to execute, then at that time port 3 will not work as a IO. Clear? Then okay. So next, that is pin 18 and pin 19. These pins are used for interfacing an external crystal to get the system clock. Now as we have discussed in architecture, that the controller 8051 will oscillate or will have the frequency, crystal frequency of 12 megahertz. So in XTL2 and XTL pin, which is pin 18 and pin 19, they will have a clock circuit in between which will generate the 12 megahertz frequency. Right? Now the clock circuit, how the clock circuit is generated, we will see in the next session. Then pin 20. So this pin provides the power supply to the circuit, right, which is connected to nothing but ground, that is 0 volt. Then pin 21, that is these pin are known as port 2. It serves as a IO port. Higher order address bus are also multiplexed using this ports. The same way like port 3, here port 2 is also working with its alternative functions, as it works as IO port, but in alternative function it works as higher order address bus. So whenever there will be a needed of higher order address bus, port 2 will work, or port 2 will provide the higher order address bus from these pins, pin 21 to pin 28, and at that time they will not work as a IO port, right? So pure port 1, that is for IO port, right? Other ports are having a alternative functions. Then pin 29. So this is a PSEN pin, which stands for program store enable. It is used to read a signal from external program memory. Now this PSEN pin is an active low pin. So whenever this pin will be 0, right, this pin will activate it, and what it will do, it will read the signal from the external program memory, the program memory which we have connected externally through the controller. From that memory it will read out the program. Clear? So if any program is stored externally in the memory, what we need to do is we need to connect with the controller, and we need to enable this PSEN pin to read that particular program. Clear? Now pin 30. This is the EA pin, which stands for external access. So input. It is used to enable or disable external memory interfacing. So again, for external memory which we have connected, when if it is accessed or not, it is used by EA. So again, it is a low active low pin. So if it is 0, it will be enabled for external memory, and if it is disabled, that is 1, then it will not connect with the external interfacing. The memory cannot be read out. Then pin 31. So pin 31, that is again ALE pin, that stands for address latch enable, and where it is used, so it is used to demultiplex the address and data signals of the port, right? The same way the pin 30 which we are using for 8085 processor, the same function ALE pin does at pin 31 in 8051 controller, right? So due to this, the multiplexed address and data bus at port 0, that will be demultiplexed using ALE. Then pin 32 to pin 39. These pins are known as port 0. It serves as IO port. Lower order address and data bus are multiplexed using these ports. So particular this port is also is used for as a IO port, but alternate functions, that is are for lower order address bus and data bus, that is AD0 to AD7, are multiplex using this code. So whenever there is a requirement of address bus or data bus, these pins will serve as a lower order address bus and data bus and will not process for the IO port, right? So if we want to access the input output device, or we need to connect the input output device, what is the first step we need to connect? That is on port 1, right? Then check out rest of the ports, port 0, port 2 and port 3. If it is not doing any alternate functions, then can it be used as a IO ports, right? The IO ports, we will see in detail each and every pin with its alternate function in detail in the next session. Then last pin, that is pin 40. So this pin is used to provide power supply to the circuit. Again for 8051, the power supply is plus 5 volt. Clear? So plus 5 volt power supply is given to here VCC, that is pin 40, to switch on this particular IC. Done? Clear? Now, so that's all for this session. Clear? Now in the next session we will going to discuss that the about the reset circuit, clock circuit of 8051, right? And in detail we will see about the input output ports of 8051 and with their alternate functions, right? So each and every alternate functions will be explained in the next session. So that's all for today's session. Thank you.